Hello, hi, I'm back. Alright, first derivative from first principles. Nice. Okay, so we know we have we have questions. Really, take them from past papers. Not just right there. Take them from past papers, because working with textbook questions is it's useful. You need to work with them, but always prioritize also working with your past papers a lot. Working with them a lot. Anyway, so we're going to have to derive this, right? So f of x must get this, right? That's the derivative anyway. Out of what? If f of x is equal to x minus 3x squared. Now that's a quadratic graph, or that's a parabola, so to say. Right, so I'm just going to zoom my work in, and right, good. Right, hopefully I can still see. Right, yeah. Okay, there I go. Right, zooming allows us to have more detail into what we're looking at, right, so that you can see also properly. So that's what we have, and that's what we're gonna work with. And what is our first principles formula? Okay, say it out. Right, give it one. So let's derive this then. What do we know? Well, first of all, I like putting x squared up front, so I have f of x is equal to negative 3 right. So I'm going to say first derivative as my formula is equal to f of x plus h minus f of x divided by nh, where the limit, as we know it, is that the h is to 0. Now I'm going to do us a favor and get f of x plus h. F of x plus h means I'm going to substitute x plus h wherever there is x. So it will be equal to negative 3 multiplied by x plus h, and there was a squared right there, plus nx plus h. That's what it means. Right, now let's go forward. Go back to my green color, nice colors to use. Alright, so I'll be saying it's equal to, substitute that, it will be negative 3 multiplied by x squared plus 2xh plus nh squared minus, right, okay, I'm not done. That's a negative 3 plus that, right, and then I have plus nx plus h. Now I'm just done writing this, so now it's equal to be minus the f of x. Now I think I feel the need to write these in different colors so that you can see evidently who is who. So I'm going to rewrite this and put it in purple, and this I'm going to keep in green, and um, negative 3x. So I'm keeping f of x in purple. Right, and minus, let's put f of x in its bracket, negative 3x squared plus x. Altogether, it's divided by the main color, which is h. And the limit, h is to 0. H is to 0. Let's go forward with our h, which is to 0. And that will be equal to, that should multiply to everyone inside. Should. So that means we are going to have negative 3x squared. Now remember the notation I used before. I said if I have 10 minus 24, I can write it as 10 minus 24. I'm going to use the same notation. I like it. Useful. And the fact that tens and tens are under each other, units and units are under each other, makes it nice. Alright, so that's and that gives negative 6 of x h, and that gives negative 3 of h squared plus n x. Let's give it its margin subtraction. Then that right there becomes negative times negative. It becomes plus 3x squared, and negative times positive x becomes minus x. All together, and let me not disrespect what we agreed on, so that will be purple. This is the last time I'm giving purple anyway. That will be purple as well, and all of this will be divided by an h, where the h is limited to 0. That's our limit as we know. Shall we go forward? Going forward, we get that this cancels that. Oh, that's 0 right there. This cancels that because that's a 0 again right there. We're adding them really. And that means we're going to end up with an equal to negative 6xh minus 3h squared plus h. All this divided by our h, of which the limit is h is to 0. And that will be equal to, factorize. Look, h is common, and that means h can come outside, and you have negative 6x minus 3h plus 1 divided by h. Limit h is to 0. H is to 0. H must approach 0. H must be gone out. And now we have, for the first time, h becoming the true thing that we know him to be, which is 0 and plus 1. So the answer is negative 6x plus 1. And you are done. You have just gotten your derivative. Right, awesome. So now we go back to 75%. Oh no, it won't take me that much time anyway. Right. Right, so we just got our answer. Now we go to the next question. There's the next question. That's the next question. Now determine the first derivative. Yes, from first principles. Good, we know that. Now, if you think you can do it, pause the video and do it, and then you can just replay to find out what is the answer. Right, so let's write it down first. What do we need to? Okay, we're just gonna zoom it in. Go up for it. Right, there we go. So there's our equation, and let's use purple. Rewrite it. It's well written, really. So just rewriting what we have. That will be f of x is equal to 5x squared minus 5x. Good. Now let's get the derivative. Then we can use our green. F derivative of x is equal to. Now notice I really robbed the colors last time, because my f of x plus h had a color. So this is the color we're going to use at the moment. Let's go and get f of x plus h. This is f of x. Let's get f of x plus h. Let's respect f of x plus h. That will be equal to 5 multiplied by x plus h squared minus 5 multiplied by x plus h. Because wherever there is x, x plus h enters. Right, and you are allowed to do this, right? As you enter your exam, and putting things on top of the denominator is stressing you, it takes a lot of time. You are allowed to do this as your first statements, solving for f of x plus h individually before you now substitute into your equation that you know. So I am more than allowed to also continue and say it's 5 multiplied by x squared plus 2xh plus h squared minus 5x minus 5h. You are allowed to do this. Just take me as if I'm already a student who's just solving his exam question right now. Yes, I will do this really. But yeah, I just put my number first, maybe it's 2.6. Don't know what it is though, then everything here is useful to the marker. And I'm going to have an answer of, just give it space and put it from here, 5x squared plus 10xh plus 5h squared minus 5x minus 5h. Please respect the sign. You see how it went on to multiply? Both nicely, neatly done. And I can only end here, unfortunately. I now have to go back to that equation, so this will be equal to, just rewrite it from here, f of x, we know that it's equal to f of x plus h minus an f of x divided by an h, and we know that the h is, and that will be equal to, you solved this already right there, right? So you're just gonna substitute it. it's going to be 5x squared plus 10xh plus 5h squared minus 5x minus 5h. There I am again, robbing the situation. I was supposed to use the same color, but it's fine so long as we get to put the purple thing. So just get the purple, get the purple. It will be minus, put it in its bracket, 5x squared minus 5x. Please always put a bracket here so that these guys can talk with the sign outside of them. Alright, so in continuation, now remember the 10 minus 24 notation. We're just gonna call it the 10 minus 24 notation, and all of this is divided by h, and we know that the h is limited to 0. It should approach 0. Now it is equal to 5x squared plus 10xh plus 5h squared minus 5x minus 5h. Right, now let's go to 10 minus 24 notation. Negative times negative 5, give it the purple. Negative times 5x squared will give you a negative 5x squared. I looked for x, I found x squared, and put them together. Now I go to negative times positive will give you negative times negative will give you positive 5x. Where is my x? This is x squared. This is x plus h. This is h squared. This is x. So I'm gonna put under him a positive 5x. Like terms play together, and it's very simple to put them here nicely. Notice, guys, you can write this whole thing as long as it has to be, but like terms sometimes will take time to notice. But if you write in this notation, whatever like terms you're having, you're already putting them in order. Here there is nothing to be like with, hence there is nothing to put. But wherever there is like terms, there you can see you've put it on your own. You've organized your work. Even the examiner shouldn't be confused marking your work. Now there we have it. Alright, all of this is divided by my h, and I know that my h is approaching 0. That's my limit. Alright, anyway, that kills that, and that kills that, and I'll be left with 10 of x h plus 5 of h squared minus 5h divided by h, where the limit is h approaches 0 always. You know what we do next? H is common, so we are going to have an h factorized, and we're going to have 10x plus a 5h minus a 5 divided. H may be cancelled, and now we come to the final moment where we know all skeletons come out of the water. So it's 10x plus 5 multiplied huge, something cubic, and well, my files or my box full of papers couldn't give me that, and so I went on and made something for us, something for us, something, guys, right? Something. So that's the one we're going to now. Now I don't need to unzoom this, but just for making sure. So there we have it. It is nicely done. You can see it, and you can screenshot it, and you can make it bigger, possibly whatever you want. That's the point. Now I went on made this one for us. For us. Use first principles to get first derivative of f of x. If f of x is that, there's the cubic thing. What most of us have been waiting for years to see. And notice, guys, x cubed. We don't end there. We can go x to the power 4. We can go a lot of other stuff up there. Now let's go with this and see what it can give us. Right. Now, give it that touch of the zoom. Okay, giving it the touch of the zoom. And there it is waiting for us. Right there on top. After we've given it a touch of the zoom. Alright. And that's our equation. Does it want to fit in the screen? Yes, it fits. Fits perfectly. And let's go with it then. Go with the flow. Go with the flow. Go with the flow. Give him a purple touch. F of x is actually equal to 3x cubed minus 2x squared plus 5x minus a 4. And derivative. No, not derivative yet. Let's go and do f of x plus h. Give him his own color. What can we give him? I hate yellow. I hate yellow. I hate. Give him blue. F of x plus h will be equal to 3x plus h cubed minus bonus 2 of x plus h squared plus 5 of x plus h minus a 4. You see, substituted my x plus h everywhere where there is x. Now let's do this x plus h cubed. Those who have not worked with expansion of cubic equations, let's just do it together, because you're going to meet something that needs you to do that. So I just do a tiny thing here on the side, and I'm going to say I know that you know that the answer is possible. X plus h cubed, that will be equal to x plus h multiplied by x plus h multiplied by x plus h. Some algebra revision, grade 10. So that means you solve one before the other. Guys, do not be confused. It's algebra, but look at this. Look at this. If I had 2 times 4 times 3. I don't just go around and say 2 times 4 times 3. I go around and I say it's equal to 2 times 12. It's equal to 24. 2 at a time. So now that means I'm going to have x plus h. Now I can do my, this was simple. If it wasn't simple, we can work it out. Now we can start to do x multiplied by x squared, which is x cubed, x multiplied by 2xh, which is going to give you plus 2x squared h, right? And x multiplied by h squared, which is going to give you plus xh squared. It's going to be a bit long. It's going to be. So we're only left with h to do. Unfortunately, I won't be able to put arrows. So we have h times x squared, which is plus hx squared. Like terms already. I prefer the 10 minus 24 notation, as you know. But it's fine. We can go on. Oh no, I love this notation. I'm just gonna say what? Okay, here it is squared, and then I'm just gonna say plus, finally, h multiplied by x squared. It will give you plus x squared h, like terms on top of each other. Nice, superb. And then I have h multiplied by 2xh, and that will give you plus 2xh squared. And then h multiplied by h squared, which will give you plus h cubed. Not like term to add with, but these two guys, they've got a lot of business together. So you have x cubed plus 3x plus 3xh squared plus an h cubed. I love this notation. 10 plus 24. 10 minus 24 is for the calculator. That is how you get the cubic thing. Right. It's worth the ride, trust me. So what you learn? You can learn how that this thing will always come out as this. Meaning, even if I was having x plus y cubed, I don't need to calculate it per se, take the whole long ride. Whereas I just know it will end up as x cubed plus 3x squared y plus 3 squared plus the y cubed. That's what it will end up as. You don't need to go the long road. But trust me, when you enter the exam and you forget, or you have a bit of anxiety attacks, and then you start to forget some things, and then you find that maybe you are going to end up putting a negative here, you're going to end up putting a negative here, you're going to end up putting a 6 here, you put 6's here and all that. You're going to start to have issues now, right? And that means you don't need to depend on memory. You can just do this on your own. You can just redo it on your own. You don't need to worry. Right, moving on. So we are now going to substitute that into our calculation. Now this is why question papers are no longer providing cubic equations that much, or giving cubic equations that much, because this thing becomes weirdly long. Look, just by solving this we got a weirdly long thing. And this weirdly long thing must be used wherever we're going now. That's so not okay. Right, so just hold on for a moment. Right, and there we go back. Not so far, not so far, not so far. So what did we learn? We learned that x plus h is solvable in a nice way. So you see now we can just sort it out, give it back its blue color. Blue is a nice color. So we are going to have, you see the work is still looking at us from the other side of the board. Now this will be equal to, just still solving x plus of x squared h, there are 3, sorry, not 2, plus 3, just my pen is, okay, 3x squared h plus a 3 again of x h squared plus an h cubed minus a 2 of x squared plus 2xh right, plus h squared plus a 5h minus a 4. Shall we go to our notation? Yes, why not? This will give you 3 of x cubed plus 3 of x squared h plus 3 of x h squared plus h cubed. And multiplied by that just give me a 3. Respect the brackets. And then now that goes to meet that, right? So we're going to say minus 2x squared. Well, we don't have that to play with here in our formula, so just minus 2x squared. Just gonna write it down here, but it's not busy with anyone, it's not likely with anyone. Please, it's not likely with anyone. So we're just gonna write minus 2x squared, and that goes to become minus 4xh and there's no constant to cancel, no one to add with. We leave it like that. Trust me, we leave it like that. We respect what we find. So let's go and do our first derivative, first principles, um, deriving. Right. So I'm gonna need to use this side more, and my first derivative will look like this. My first principal thingy will look like this. F of x, first derivative, will be equal to f of x plus h minus f of x divided by an h where the limit is that h must be approaching 0. Let's go for it then. F of x plus h. We solve for f of x plus h, and the h is that huge thing we have there. So we're just gonna have it as 3x cubed plus 9x squared h plus 9x h squared plus 3h cubed, right? And it has minus 2x squared minus 4x h minus 2h squared, and then it has plus 5x plus 5x plus 5h minus 4. A long thing to deal with, right? Long thing to deal with. And this is where you need to be very cautious of your signs, because it's extremely long. Examiners are trying to keep this out of the exam because really students end up losing marks. Look at how huge this thing is. Huge. Now let's just go and get our f of x. There's our f of x, and it's in purple. Our f of x right, and we're supposed to subtract it. So in subtraction, an appreciation of subtraction, we are going to now put this under our 10 minus 24 notation. How is that going to work out? We are going to say, remember, the negative must affect this whole thing. So do this for yourself. Write it on a side with a pencil. Negative, right? With a pencil, please. With a pencil. Negative multiplied by 3x squared minus 2x squared plus 5x minus 4. Just trying to make sure it fits nicely. So that will have the negative going into the whole thing. So we're just trying to make this right. This. Just making this what we have here. Looks like a mess right now, but it's okay. And that works with that, and that works with that, that works with that, and that works with that. Respect the signs. That's why I'm doing it on the side, so that signs are respected before I add it into this whole thing. Oh, this is cube, sorry. So now this would be negative, so I put it under my x cubed because it's like terms, and this will be positive, so I put it right here, and this will be negative, and this will be positive. Also a tip, notice whenever you do derivative, your equation will always be cancelled out. Everything about f of x will be cancelled out. Please take note of that. That means, you see, even 3x squared is all about f of x. Even though it's coming from the f of x plus h, it's going to be cancelled out. So that's one of the tips. If it's not cancelling out, there is something wrong with what you have. Alright? There is something wrong with what you have. Now, all of this must be divided by an h. Wherein you know your limit. Yes, you do. Yes, you do. You do know your limit. You do know your limit. Your limit is h is to 0. Your limit is h is to 0. Now hold on for a moment. And that is our last question. Once we're done with this one, we move into power rule. Your limit is h is to 0. Now, because you have that, it's equal to, go down with it, right? That went that went that way, and that went that way, that. Now you have what? You have a 9x squared h plus a 9x h squared plus a 3h cubed minus a 2h squared plus a 5h all together divided by h, where the limit is h is approaching 0. Continue with it. You will find that h is quite a commoner. There is, there is, there is, there is, and there is. And it's 1h common because there's 1h as the lowest degree. Then you have 9x squared plus 9xh plus 3h squared minus 2h plus 5 altogether divided by h, where the limit is h is to 0 and it's equal to that, cancels that, and now you have what? The first time ever h comes out of his box. 9x squared plus 9 multiplied by x multiplied by 0 plus 3 multiplied by 0 squared plus 5 plus 5. Now I'm just noticing that there could be something wrong, and that's when you start to have to check your equation. Perhaps if you left something or something, but we're going to check it out. We're going to check it out. This thing is supposed to be enormously a bit bigger than what we are looking at. It should be a bit bigger. I wonder what is missing. I wonder. Right, because the 0 went in well. 0 went in well. So plus f5, and that will give you 9x squared plus 5. Now let's go and check and see what is it that is missing. What is it that is missing? 9x squared h, 9x squared h, 9xh squared, 9xh squared, 3h cubed, 3h cubed, minus 4xh, not here, minus 2h squared, not here. Okay, minus 2h squared is here, plus 5h, minus 4x, not here. So just put minus 4xh here. That's the guy who was missing the whole time. He was missing. So when we were factorizing, he was supposed to be inside minus 4x, right? And in case anyone is confused on this one, you're more than welcome to ask for a redo on everything. But the 4x was missing, and it's a minus 4, so it could be put in between. It's minus 4, it's fine. It can be put outside as well. It's minus 4. You don't need to worry about it. Now we had to adjust the bracket, put it back in. There it is. And you notice the h is factorized, right, out of it. So that means it's now 4x, just like others, and h was factorized. Now after that, you go to solving it, right? And wherein there is a minus 4x here, right? The h was cancelled for everyone, you see, and the 4x will just drop the same way. Now after substituting a 0, this is 0, right? This is 0, this is 0, so this will be plus 5 minus 4x, and then your answer will be what? 9x squared minus 4x plus 5. That will be your derivative. Now notice how when it's long, you need to take care of your signs. 1, 2, you need to take care of your terms. Sometimes when we're marking, we do come across disappearing terms. Look, I myself had to notice that yes, there is a term that went somewhere. There is a term that did not follow up with others, and I had to go pick it up, put it back, right? So that's one of the most important things to notice. And I could take away these mistakes and make this a perfect video, but it's also quite important that you notice how you need to close up on these gaps, and you need to notice these things, right? Now what made me notice that I had something missing, you need to be able to use your first your rules, your exponential rules that you're gonna have in deriving, which are the easiest ways that you can use to solve this, right? So just to put this back into what you expected, what you expect is a good page. Right, and there we have it. There it goes. You can screenshot, you can zoom, you can do whatever you want, and that is our answer. It's 9x squared minus 4x plus a 5. That's your answer. You would have derived. Now we are going to now introduce the exponential rule of deriving, and that is what is going to make it simpler. After that, we have back towards the meaning of terms like stationary points, inflection points, instantaneous gradient, and we step into calculus optimization. And from there you should be well put with calculus grade 12. Right, that's it.